Hi there, this video is an exam paper walkthrough of the AQA GCSE Mathematics Higher Tier Paper 3 from summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 9 to 14, which account for 21 of these marks. AQA Paper 3s are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. The pie chart shows information about people at a fair during 3 days. So we've got Thursday, Friday and Saturday. There are 132 more people on Friday than Thursday. Work out the number of people on Saturday. So they've given us some information to compare Thursday and Friday. So let's work with that first. So Thursday has got a 25-degree sector and Friday has got an 80 degrees sector. So the difference between those two angles equates to 132 more people. So 80 degrees subtract 25 degrees is 55 degrees. So this 55 degrees is equal to 132 people. And again, I'm going to use a proportion table. So if the degrees, and this is people. So what I want to do is I want to find out what 1 degree is equal to in terms of people for that pie chart. So 55 divided by 55 would tell me what 1 degree is. So I divide by 55 on the other side. So 1 degree is equivalent to 2.4 people. So this is useful, but I don't know how many degrees Saturday is worth in that pie chart. So this is a full circle, so they should add up to 360 degrees. So I'm going to take 80 and 25 away from 360 to find out the angle for Saturday's sector. So I know that Saturday is now worth 255 degrees. So if I want to work out 255 degrees worth of people, to go from 1 degree to 255, I'm going to multiply by 255. So I will do the same here. So 2.4 multiplied by 255 is 612. So that tells me there was 612 people on Saturday. Question 10. Use trigonometry to work out the value of x. So the first thing I need to do is label the sides. So the side directly opposite the right angle is the hypotenuse. Opposite the other angle we're given is the opposite, which means this side must be the adjacent. Now I need to figure out what sides I have information for. Well, I'm looking for x, which is the opposite. So we're going to use that side. But I'm also given the value of the side for the adjacent. So I'm using the opposite and the adjacent in this one. So to remember the trigonometric ratios, you might have heard of SOHCAHTOA. So we want O and A. Well, the only triangle here that has O and A in is this one. So we don't need these two. And we're going to use this formula triangle here. And T is for tan. So we have tan of the angle that they've given us is equal to the opposite divided by the adjacent. So that's divided and that's multiply. I know that the opposite is x. That's what we're looking for. And I know that the adjacent is 46. So I've simply substituted in what I know. Now it's a case of solving for x. So with this formula triangle, it works like the speed, distance, time triangle. I'm looking for the opposite side. So if I cover over the opposite, it's telling me to do tan multiplied by the adjacent. So I'm going to do tan 58 multiplied by that 46, which is the adjacent. So tan 58 multiplied by 46, which gives me 73.61538834. Now it doesn't tell me anywhere to round it, so I can put that whole thing on the answer line, or I can round it if I want to. If you round it, that's okay. Just make sure you're rounding it correctly just in case. I would just simply put all of those values on the answer line. Question 11. Millie is estimating the value of this calculation. She rounds each decimal number to one significant figure. 11A. Work out Millie's estimate. You must show your working. So she's rounding each decimal to one significant figure. So the first decimal is 8.34. So we're going to round that to 8 to one significant figure. The second decimal is 10.21. So we're going to round that to 10 to one significant figure. So now I'm going to replace the decimals in this calculation with the two rounded values. So we have 1, and then we have the cube root of 8 squared multiplied by 10. And then we're going to pop that in our calculator. Making sure we have brackets around that cube root, so the whole thing is squared multiplied by 10, and then press equals. So that is 0.025. And we're going to put that on our answer line. So 11B, Millie says, my estimate must be more than the exact value. Without working out each value, give a reason how she can know this. So her estimate is 0.025, and what we've done is rounded 8.34 down to 8 and 10.21 down to 10. So we've rounded them to smaller values, so we're going to end up dividing by a smaller value. But if we were working it out exactly, the value that we're dividing by is going to be bigger, so the answer would be smaller, which is why this answer is more than what the exact value would be. So we need to give a reason. So rounded both decimals down, meaning we divided by a smaller number, giving a bigger solution. Question 12. Here is a biased spinner. So we've got a spinner here that has a section for red and a section for green. It's a biased spinner because you've got more chance of landing on green than you do red. 12A. Ali, Ben and Carey want to know the probability of spinning red on the biased spinner. They each spin it and count how many times it lands on red and divide by the total number of spins. Ali says, I spun red the most times. Ben says, I spun the spinner the most times. And Carey says, my relative frequency of red is 0.25. Who had the best estimate for the probability of spinning red? Give a reason for your answer. So Ben has the best estimate because he carried out the experiment the most times. The more times you carry out an experiment, the more accurate the results are going to be. So he spun the spinner the most times. Okay. 12B. Dev spins the spinner 80 times. He says, my relative frequency of red is 0.185. Give a reason why his relative frequency must be wrong. So we can use his relative frequency and multiply that by 80, and that will tell us how many times the spinner lands on red. So 80 times 0.185 is 14.8. So this is why his relative frequency is wrong. We can't land on red 14.8 times. It's not a whole number. Okay, 12C. Elena spins the spinner 125 times. The relative frequency of red is 0.32. Work out how many times the spinner lands on green. Now, if we remember from the original part of the question, the spinner can only land on red or green. There are two options. If the relative frequency of it landing on red is 0.32, if we take that away from 1, because probabilities sum to 1, then the relative frequency of green is 0.68. So now we can multiply that relative frequency by the number of times Elena spins the spinner. So that tells us it landed on green 85 times. Question 13. Charlie is driving 293 miles home. He leaves at 9 a.m, travels the first 176 miles at an average speed of 48 miles per hour, and then drives the rest of the way at an average speed of 65 miles per hour. Will he be home by 2:30 p.m? You must show your working out. Okay, so we have a total distance of that 293 miles that Charlie needs to travel. So he travels the first 176 miles, the distance of 176 miles, at a speed of 48 miles per hour. So let's see how long that took him. So speed, distance, time. If we're working at the time, we're doing distance divided by speed. So 176 divided by 48. And then we're going to multiply by 60 because I don't want it in hours. I want it in minutes. 220 minutes. Purely it means I'm not dealing with awkward decimals. That came out as a third, so it would have been a recurring decimal. So let's deal with it as minutes for now. And then it drives the rest of the way at an average speed of 65 miles per hour. So the rest of the way will be the total distance, take away the distance travelled already. So 117 miles at a speed of 65 miles per hour. So let's see how long that's going to take. So distance divided by speed. Times it by 60. So that's 108 minutes. So 220 minutes plus 108 minutes gives us the total time for the journey. $328 minutes. Okay. So in hours, let's divide that by 60. So that's 5 hours. 28 minutes. So if he leaves at 9, is he going to be home by 2:30? So 9 a.m. plus 5 hours is going to be 9, 10, 11, 12, 1, 2 p.m. And then add that 28 minutes, it's going to be 2:28 p.m. So yes, he makes it home by 2:30. Question 14. Kieran paid income tax and national insurance on her annual salary. Income tax. She paid 0% of the first £12,570 of her annual salary and then 20% of the rest of her annual salary. National insurance, she paid 0% of the first £9,880 of her annual salary, and then 13.25% of the rest of her annual salary. Kieran paid £5,186 income tax. How much national insurance did she pay? So, 0% of the first £12,570 of her annual salary, but 20% of the rest. So that 20% must be 5,186. So if 20% is 5,186, we can find out how much the rest of her salary was after the 12,570 by finding out what 100% would have been. So 100 divided by 20 is 5, so I need to multiply by 5. So 5,186 multiplied by 5. So 25,930. So that's how much of her salary she paid 20% tax on, but she would have paid 0% tax on this amount. So we're going to add those two together. And this will tell us what her annual salary is. So every year she earns £38,500. So this is the salary. Okay, so national insurance, she doesn't pay anything on the first 9,880. So if we take away 9,880, so she's going to pay national insurance on the remaining 28,620. So national insurance will be 13.25%. So 13.25% is 0.1325 as a decimal. So that's what I'm going to use as a multiplier here. I'm going to multiply this remaining salary by this multiplier to find that 13.25%. So 28,620 multiplied by the multiplier for 13.25% is £3,792.15. So that's how much national insurance she paid.